thank you all for being here, hanging on to the very end, last session of the day. I love your commitment. My name is Cameron Stewart, and as Laura mentioned, we're going to be talking about the Cloud Foundry container runtime. Also echoing Laura's statements, you can rate this session in the app or make a note for any questions that you might have. So we're going to talk about the Cloud Foundry container runtime, which is BOSH managed Kubernetes. So again, my name is Cameron Stewart. That's my Twitter handle if you hang out on the Twitters. To be fully honest, I don't really hang out on the Twitters, but I'm at an open source conference, and so I'm going to give you my Twitter handle. It's like Geico, it's what you do, right? So that's how you can find me on Twitter. Where I typically hang out is in the Cloud Foundry community. That's the open source community where I typically frequent. Anyone in here familiar with the Cloud Foundry ecosystem? A couple of people, all right. But that's not quite what we're going to talk about today. We'll touch on it a little bit. Where we begin our tale for today is with Kubernetes. Has anyone in here heard of Kubernetes? A couple more hands, maybe. I would expect almost every hand to go up, but that's all right. We're going to educate everybody, familiar and not. So we're going to start off with what Kubernetes is, and with the risk of preaching to the choir too much, I'm going to try and be succinct and brief in this. We all know that Kubernetes is an open source platform for managing containerized workloads. So it's a container orchestration tool. It's brought to you by Google, open sourced in 2014. I think version 1.0 went live sometime in 2015. So still a relatively new kid on the block, if you will. And it's a descendant of Borg. And I'll go into that a little bit more and why that's important later on in this presentation. It has a Linux foundation supporting it, the Cloud Native Computing Foundation, that has upwards of 170 members. So that's pretty impressive and really speaks to the adoption of Kubernetes within this community because, again, it's only been around for a little over 2.5 years or so, and it's already up to 170 members. The other thing that I think is important to understand about the Cloud Native Computing Foundation is that it's not called the Kubernetes Foundation. It's called the Cloud Native Computing Foundation, which is indicative of Google and the governing members, kind of their view on Kubernetes. They understand that it's part of the cloud native transformation, and it's a big part, but it's not the only player. They want to encourage the ecosystem to flourish around Kubernetes. So they realize that there are going to be other tools and other services that are going to be involved, that are going to surround and support Kubernetes, and that's going to be important to the overall effort and venture of becoming cloud native. And the community has really responded, right? Even in the short time that Kubernetes has been around, there's a rich ecosystem that has developed around it. So that's, again, speaks to kind of the adoption and the market domination that Kubernetes has, that we've come to expect and come to see in Kubernetes. And as you will oftentimes see with open source software, there are different versions, different distributions of it. Everyone kind of wants to take Kubernetes and put their own spin on it. And because there is such rapid adoption and growth of distributing Kubernetes, last November, Google and 36 of the Cloud Native Computing Foundation members got together and set out a set of standards around all of these different Kubernetes distributions. So what that means as a user is that you can expect a consistent experience when switching between Kubernetes versions. So as a user, this is a really nice thing that you're not going to go to one version and have it be incompatible if you were trying to go to another version of Kubernetes. So it gives you that workload portability among different Kubernetes versions and distributions. So what makes Kubernetes great? That's what Kubernetes is, what's contributed to, or what's been driving this mass adoption that we've seen of Kubernetes. And I want to focus up on the pink text up at the top. Ideal for packaged apps, apps and services exposing multiple ports, and where finer grain control is needed. I mentioned that I kind of hail from the Cloud Foundry community, and Cloud Foundry's been around for a while, and what it's really been known for and it's found great success in is providing an application runtime. And this application runtime has really been ideal to run a certain subset of workloads. We're talking about your cloud native, greenfield, stateless microservices. Those runtimes work and run fantastically on Cloud Foundry. But what we identified is that those workloads aren't representative of the entire application portfolio within any given organization. There are other types of workloads. And so that's really where we're going to talk about the Cloud Foundry container runtime. But in looking at Kubernetes, that's what Kubernetes offers. It offers you a runtime for applications where that finer grain control is needed. In the Cloud Foundry ecosystem, there's a really awesome haiku, which is written by a gentleman who works at Pivotal named Ansi Fakhouri. And this haiku is meant to encapsulate the developer ethos that we're trying to accomplish with Cloud Foundry. And it goes something like this. It says, here's my source code, run it on the cloud for me. I do not care how. And that developer ethos that we're trying to capture is that as a developer, you just want to be able to write your code and then deliver it to end users. And everything that has to happen along the way in order to deploy that code, the developer really doesn't want to care about that. Well, that ethos is a little bit different in the Kubernetes ecosystem. It's something like, here's my source code, run it on the cloud for me, let me tell you how. So there is that finer grain control, which is what you get with Kubernetes. So that's the difference in kind of the two different runtimes that we've talked about. So Kubernetes is great for your containerized workloads, whether you're building those Docker containers, let's just say, in-house, or potentially an ISV partner is providing their application to you in a containerized package. It's really great for stateful services, so services that use persistent storage, things like MongoDB, Cassandra, Spark, Elasticsearch, services like that. And then again, that customization, so you can specify and have more control over how your application is deployed and operated, which oftentimes can increase your application performance. But don't take my word for it. Why is Kubernetes great? This is a kind of an eyesore of a quote, so I'm just going to summarize it for you. 451 Research did a container survey in 2015, and 10% of respondents, just 10%, said that they were using some sort of container orchestration tool, whether that was Kubernetes or some other container orchestration tool. Well, that survey was run again 2 years later as a follow-up. What we found was that 71% of respondents said that they were using Kubernetes to manage their containers. So again, in just 2 short years, the adoption of Kubernetes has just been going gangbusters. And so looking at a Google Trends here, this is comparing Kubernetes to Apache Mesos and Docker Swarm, and you can see that Kubernetes has a steeper trajectory, shall we say, than other container orchestration tools. So there's no denying it. Kubernetes is here to stay. Everyone loves it. That's great. But it's not all rainbows and sunshine, right? The reality is that there are some things that are really difficult about Kubernetes, and really what that all boils down to is operationalizing Kubernetes. So when we talk about high availability, scaling, health checks and healing, and upgrades, all of those things are really, really difficult with Kubernetes. So there's no out-of-the-box fault tolerance for your Kubernetes components like your masters and your etcd nodes. Similarly, you can scale, and Kubernetes will run health checks and healing on the worker nodes, but for the Kubernetes components, like the cluster components themselves, your master and your etcd nodes, you can't, there's no out-of-the-box and easy way to accomplish those things. And then again, to do a rolling upgrades or just upgrades in general of a fleet of Kubernetes clusters, that's really, really difficult, and who's responsible for managing that? But again, don't take my word for it. This quote comes from an engineer at Garmin. Spoken like a true engineer, he said it's fun, but it's challenging. This was a talk given at VMworld, I believe, last August, and the talk was given by Cornelia Davis, who works at Pivotal, Paul Duell, who works at VMware, and they invited this gentleman, Brandon Henry from Garmin, on stage with them, and Brandon is responsible for running and operating their Kubernetes platform. And essentially, he broke down the challenges that they have seen with Kubernetes into a couple of different themes. It was, cluster administration, cluster scaling, tooling, security, or logging, monitoring, and security. And he, throughout the talk, talks about all of the additional tools that he needed to bring in order to achieve things like scaling your cluster, things that weren't functionality built in inherently and natively into Kubernetes, and all of the different tools that he needed to bring in order to be successful with this. And all of those tool sets are difficult, and that introduces a lot of complexity into your ecosystem. Outside of just introducing complexity to your overall architecture, the skill sets that are required are, non-trivial. So after kind of Brandon talked about some of the challenges they faced with operationalizing Kubernetes, Cornelia Davis took over the talk and said, thanks, Brandon, he's just your run-of-the-mill average unicorn, right? And that's totally true. The skill set that he has to have in order to work with all of those different tools and how to use them all together to be successful and, leveraging Kubernetes as a true holistic platform, that's no joke. So the skill sets that you need are serious. So now we're going to switch gears a little bit, and we're going to talk about BOSH. And BOSH is a component, again, it's deep in the Cloud Foundry stack. It's really, I like to say, at the heart of Cloud Foundry, and we're going to talk about it a little bit. So BOSH is, this is the definition for BOSH. It's an open source toolchain for release engineering, deployment, lifecycle management, and monitoring of distributed systems, which is a mouthful. So we can kind of unpack this a little bit and talk about each one of these things. So with BOSH, it gives you release engineering capabilities. So it allows you to do rolling upgrades using canary-style deployment so that you have zero downtime. It gives you deployment capabilities across multiple different infrastructures and different cloud providers. Lifecycle management, I'm going to actually skip ahead to monitoring. Because of lots of monitoring that is built into BOSH, it gives you an easy way to manage the lifecycle of your workloads. So because of the high degrees of monitoring that are included within BOSH, it also will give you self-healing and resurrection for your workloads. And then finally, distributed systems. So BOSH deploys and manages distributed systems. So essentially, it's a cluster manager. So whether those distributed systems are Cloud Foundry in one case, or it could be WordPress, or maybe we'll see later on Kubernetes. So at its core, BOSH is a cluster manager. And there are, if we kind of go back to the previous screen and look at some of these words, we see release engineering, we see deployment, we see lifecycle management. All of those are very DevOps-y terms, if you will. Those are terms we would expect to see in a DevOps conversation. And it really boils down to the DevOps pillar of treating your infrastructure as code, automating how you interact with your underlying infrastructure. And we know that this space, there are lots of different tools that are available within this space. This space has gotten a little crowded, you might even say. And there are lots of comparisons that have been done with some of these tools. So we've heard of Chef versus Puppet, Chef, Puppet versus Ansible, et cetera, et cetera. But BOSH has always largely been left out of the comparison conversation. And so there are two gentlemen from Pivotal that wanted to have that conversation. And so they wrote a two-part blog series, which again, I've linked here at the bottom. I highly recommend you go and check it out because it's a great blog series. But it compares BOSH against Ansible and Chef. And what it wanted to do was to take a kind of real-life example of a cluster that it could compare all of these different tools against. And so it decided on RabbitMQ cluster. So, and then it wanted to test these tools basically throughout the entire life cycle of an application, which they broke down into 5 different categories: packaging, provisioning, deployment, monitoring, and upgrading. And so if you think about those 5 different stages, they really align nicely into 2 buckets that we largely hear discussed as day 1 and day 2 operations. Has anyone heard of day 1 and day 2 operations? Yeah, okay. So the first 3 of those, packaging, provisioning, and deployment, those all really nicely fit into the day 1 operations bucket. And then monitoring and upgrading really fall into the day 2 operations bucket. And so in comparing these 3 tools, for the day 1 operations, the packaging, provisioning, and deployment, all of these tools were pretty even. I mean, they all did things kind of in their own way, but the end result and the functionality that they were able to deliver was largely the same. None of them really outshone one or the other in this process. But to kind of skip to the punch, and this is a little bit of a spoiler alert, when it got to those day 2 operations, so the monitoring and the upgrading, that's where BOSH really started to pull away, and where they really saw BOSH as having far and above a different and unique capability that the other two just couldn't quite deliver. So to look at it another way, there are tools out there for configuration management, which, again, we see some of those stages that we talked about in the previous slide here. We see provisioning, we see packaging, job consistency. All of those are kind of functionality that you would expect to see with a configuration management tool. And then there are other tools out there that are orchestration tools. So they build on top of this base functionality of configuration management, and they add things like service discovery and lifecycle management. Again, that's something that we were just discussing. And so then we take it even further, and BOSH builds even more on top of what those two different tool sets will provide, and really gives you kind of, again, those day 2, those things that you'll need to take into consideration for your day 2 operations. Things like backup and restore and recovery, cross-cloud portability. So not just being able to run your workloads in different clouds, but to completely move from one cloud to another, how to do that in a pretty seamless and easy way. Monitoring and alerting, the ability to do rolling updates with 0 downtime. These are all of the additional capabilities and features that BOSH really delivers that other orchestration or configuration management tools just simply can't deliver. So this is one of my favorite quotes, and it comes from Andrew Clay Schaefer, and he says, "Day 1 is adorable and day 2 is forever," which is pretty appropriate, especially since Andrew Clay Schaefer is the man who actually coined the term DevOps. So that sounds like something that the founder of DevOps or the founder of the term DevOps would say. And this, again, really goes back to the power of BOSH, because it's those day 2 operations that really, really matter. I mean, it's obviously important to deploy something, but then to continuously upgrade, patch, and keep that online 24/7 for users around the globe, I mean, that's really where the meat of the issue is, that day 2 is critical. And so that's where BOSH is really our hero in that space. So if we talk about some operational challenges, again, broken down into these 2 different buckets, day 1 and day 2, some of the challenges that you could expect to see with any platform. So for day 1, again, this is all about your deploy or your build. And so you want to be able to provide a reliable experience for any cloud. So not having to have different configuration or to have Snowflake environments regardless of the underlying infrastructure that you're running on. You want to allow for open APIs. You want to have the more the merrier attitude where your operators or your developers can use a rich array of different tool sets. And you want to be able to have a consistent environment, regardless of the tool sets that you're using or the underlying infrastructure that you're running on. You want to have a consistent experience. And then setup time. How long does it take to set up an environment? We really should be thinking in units of hours as opposed to days or weeks. And then on the day 2 side, when you really have to operate a platform, the considerations that you really have to think about are patching. So to patch components that have thousands of applications running on top of them shouldn't be a big event. You should be able to seamlessly scale your platform components. You should be able to roll out new versions of the platform. Again, with during business hours on a Tuesday, it shouldn't have to be this big event with lots of ceremony around it. And then your operating effort should be minimal. So if you have to have an entire, platforms are supposed to give you kind of operational efficiency is what we say. But if you have to have an entire team of people operating this platform, are you really, benefiting from that operational efficiency? So these are some of the challenges that you could potentially run into with any platform. And so where BOSH really comes in, if we talk about where BOSH really shines in some of those different day 1 and day 2 considerations, BOSH comes with an embedded OS. So you don't have to worry about owning or being responsible for the OS. It comes with a hardened OS image that is provided by BOSH. One of the key benefits that we talk a lot about within the Cloud Foundry ecosystem is that BOSH gives us the ability to be IaaS agnostic, so you can run on any cloud. So BOSH allows, for instance, in the example of Cloud Foundry, you can run on top of any of the big 3 public cloud providers, OpenStack, and a vSphere environment, et cetera. So BOSH gives you the capability to provision servers across any IaaS. There's a communication layer called the CPI, the Cloud Provider Interface, which is the communication layer between BOSH and the underlying infrastructure. So there's a CPI that exists for each underlying cloud. There's a CPI for AWS and for GCP, and that's the translation layer that communicates with that IaaS-specific language back to BOSH. So that's what allows BOSH to be what we say is IaaS agnostic. And then to deploy your software across your cluster. And so then for the day 2 side, we think about, again, the monitoring that is built right into BOSH, and that will give you self-healing via a component of BOSH called the Resurrector. And then finally, you can do rolling upgrades via canary-style deployment, which is what allows you to have a 0 downtime deployment. So you can roll out a new version of your software in a rolling style, again, as a non-event with 0 downtime. So you can do this during business hours on a Tuesday, as I like to say. So I mentioned that BOSH is a cluster manager and that it deploys and manages distributed systems. And so what those distributed systems represent in the BOSH world, again, whether it's Cloud Foundry, Kubernetes, RabbitMQ, doesn't matter. Whatever that distributed system is, that's known as a BOSH deployment. And so if we talk here about the anatomy of a BOSH deployment, it's 3 main components that make it up. It's the stem cell, which is a secured, versioned, hardened OS image with IaaS-specific packaging wrapped around it. A release is what you are deploying. So it's a versioned collection of configuration templates, configuration properties, source code, binary artifacts, startup scripts. It's whatever is needed to deploy software in a reproducible way. And then the manifest, so it has a declarative manifest. So BOSH operates on the notion of eventual consistency, which is where you provide it a desired state, and you set that desired state in a manifest, you declare it in your manifest. And then BOSH is constantly pinging the system to see what the actual state is of your cluster. And if there's a discrepancy between the actual state and your desired state, so for instance, if you say, I want 3 nodes always running and there are only 2 running, it will automatically resolve that discrepancy for you. So it's constantly evaluating desired state, which again, you declare in your manifest, versus actual state. That also means that in order to make an update to the system that BOSH is managing for you, all you have to do is change a value in a manifest and then issue the BOSH deploy command, and it'll roll out that change, again, in a rolling fashion so that you have 0 downtime. One final thing about BOSH is that BOSH is based on Borg. Is anyone here in the room familiar with Borg? Yeah. So Borg is a component that came from Google, and it's responsible for running services like Google Search and Gmail. So it's a pretty powerful tool. And so the Cloud Foundry team hired 2 gentlemen that worked at Google, and they were kind of top flight SRE types that contributed to the creation of Borg. Hired them early on, I think back in 2012 or something like that. And they said, we really love Borg. We'd like to use something like Borg, but we wanted a little different. They wanted Borg++. And so the name of BOSH is actually Borg++. So if you take the last 2 letters of Borg, which is R and G, and you increment them by 1, you're given the name BOSH. So R+1 is S, and G+1 is H. So that is where the genesis and the name of BOSH came from, is that it is literally Borg++. And so what is important to know that BOSH is based on Borg is that within Google, Kubernetes is meant to run in tandem with Borg. And so when you combine BOSH with a container orchestration engine like Kubernetes, true magic is what happens. So let's talk about what can happen when you combine Kubernetes plus BOSH. When you combine Kubernetes plus BOSH, you get Kubo. So you get the Ku from Kubernetes and the Bo from BOSH, you get Kubo, not that Kubo, Project Kubo, which was a collaboration between Pivotal and Google. So it was a joint engineering effort. Pivotal is the main contributor to the Cloud Foundry, open source project Cloud Foundry, so it contributes, I think, 70% to that project. Anyway, so Pivotal and Google came together and did Project Kubo. I think it was announced last March. They donated it to the Cloud Foundry Foundation, which is similar to the Cloud Native Computing Foundation, a Linux foundation that supports the open source project Cloud Foundry. They donated it to the Cloud Foundry Foundation in June, and since then it's been incubated, and it's actually gone through the incubation phase and is now a supported component within the Cloud Foundry ecosystem. So throughout that process, it went through a little bit of a rebranding. And so what we arrived at, probably because there was too much confusion with the two strings guy. Anyway, Kubo is no more. It's important to know that because some of the, like in some of the documentation and in interacting with the Cloud Foundry container runtime, sometimes you'll see Kubo referenced. So it's important to know that it was, formerly known as Kubo. Now we've arrived on the lovely mouthful of a name, Cloud Foundry Container Runtime, which again is the BOSH managed Kubernetes. So what is Cloud Foundry Container Runtime? So with a BOSH director is essentially what the control plane for deploying and managing the lifecycle of the systems that it's deploying. So BOSH will provision you a Kubernetes cluster. And then from there, it's the same interaction that you would expect or that you've come to know with interacting with Kubernetes. You can access it via the CLI kubectl, which will go through an IaaS-specific load balancer, communicate with your API server, and again, everything is pretty much standard Kubernetes from here. Each Kubernetes cluster that gets deployed via the BOSH director is deployed in its own subnet. But if you think back to what this is and kind of that BOSH deployment anatomy slide that I showed you, this is just a BOSH deployment. So again, there's different, a BOSH deployment is whatever the distributed system is that you're trying to deploy, whether it be Cloud Foundry or in this case, the container runtime. So what does this give you, or what problems does this solve? The multi-cloud, again, giving you a consistent experience, having a single control plane, if you will, regardless of the underlying infrastructure that you may be deploying Kubernetes on. High availability and multiple AZ support. So BOSH allows you to deploy and distribute both your master, your worker, and your etcd nodes across multiple availability zones, and we'll keep them up. BOSH gives you 4 levels of high availability, which we'll talk about in just a second. Scaling and VM healing. Currently, Kubernetes allows you to scale and will watch and monitor the workloads of the workers themselves, the workloads and the workers that the workloads are running on. But for the masters and your etcd nodes, there's no scaling or VM healing built in for those components. So that's where BOSH really comes in and will do that for you. And then also, in order to do an upgrade or to scale your cluster, we talked about a BOSH manifest where you can simply update your value in that manifest, hit a fresh BOSH deploy, and boom, you're in a new state. So I wanted to just double click on one of those really quickly and talk about the 4 levels of high availability that BOSH gives you. The 4 levels, which you can think of as kind of going down the stack, are availability zone, VMs, processes, and the actual workloads running on top of your components. So BOSH gives you the ability to distribute your workloads across availability zones so that if you lose an entire availability zone, BOSH will redistribute the workload from that availability zone that went down to the remaining capacity that you have in your other availability zones, so that you're not impacted by that availability zone going down. Similarly, if a VM goes offline, because again, BOSH is constantly polling for eventual consistency and saying I should expect 5 VMs and I only have 4, it will recreate that specific VM and redeploy whatever was running on top of that VM. Processes are monitored so that if a process goes down, it'll be restarted. And then if a workload, so if a pod were to die, BOSH actually doesn't have anything to do with this because this is functionality that is built into vanilla Kubernetes. Kubernetes will bring back its workloads. So Kubernetes, native Kubernetes is handling that, but the other 3 levels of high availability that you get are provided by BOSH. So that gives much more resiliency. Your cluster can benefit from much more resiliency thanks to BOSH. So that's a summary of the Cloud Native or the Cloud Foundry Container Runtime, which is a new runtime in the Cloud Foundry ecosystem. Again, previously we've always had the application runtime, which is great for your 12-factor cloud native applications, but now we additionally have a container runtime leveraging Kubernetes so that we can capture even more of those workloads, of containerized workloads. So we're trying to really broaden the scope within the Cloud Foundry community to capture more workloads, and the Cloud Foundry Container Runtime is the latest and greatest that we've come up with. So thank you very much. Don't forget to rate this session, and that's it.